In software development, we're always looking for ways to make applications more efficient, scalable, and responsive. This is where event-driven architectures come into play. Think of your application as interconnected components, each listening for specific events. Events could be a new user signing up, an order being placed, or a sensor reading changing. Azure Functions, Microsoft's serverless compute platform, excels in this event-driven world. Functions are triggered by events, perform a task, and then exit. Azure Service Bus is a robust and scalable messaging service. It acts as a central nervous system, delivering messages reliably. Integrating Azure Functions and Service Bus is powerful for cloud-native applications. In distributed systems, reliable communication is paramount. Azure Service Bus excels as a messaging backbone. It ensures messages are delivered reliably, even if the receiver is offline. Service Bus offers queues and topics for messaging. Queues provide one-to-one communication. Topics enable a publish-subscribe model for multiple subscribers. Features include message scheduling, dead letter queues, and robust security. It integrates seamlessly with other Azure services. Before we can start sending and receiving messages with Azure Service Bus, we need to create a Service Bus namespace. Think of this as your dedicated messaging region within Azure. Head over to the Azure portal and search for Service Bus. Click on Create and you'll be guided through a simple process. You'll need to provide a unique name for your namespace, choose a region where it will be hosted, and select a pricing tier that aligns with your expected usage. Once the namespace is created, you'll find essential details like the connection string. This string acts as your authentication key for interacting with the namespace programmatically. Store this connection string securely. We'll need it later when we configure our Azure function. With our Service Bus namespace ready, we can move on to building the heart of our event-driven application, the Azure Functions. Azure Functions are the building blocks of modern event-driven applications on the Azure platform. They embody the serverless computing paradigm, allowing you to focus solely on the code that matters without worrying about infrastructure management. Imagine functions as small, self-contained units of code that spring to life when triggered by an event. These events can originate from various sources, including HTTP requests, changes in storage blobs, timer triggers, and of course messages from Azure Service Bus. When creating a function app, you'll choose a hosting plan. The consumption plan, ideal for event-driven scenarios, automatically scales your functions based on demand. You only pay for the compute time your functions actually use. You'll also select a runtime stack, aligning with your preferred programming language such as .NET, Node.js, Python, or Java. In the next section, we'll walk through creating your Azure Function app, setting up the appropriate hosting plan, and choosing the runtime stack that suits your needs. Section 5, creating your Azure Function app. Now that we have a good understanding of Azure Functions, let's create one. Head over to the Azure portal and search for Function app. Click on Create to start the process. You'll be prompted to provide a unique name for your function app, choose the region where it should be hosted, and select the runtime stack that aligns with your preferred programming language. For this example, let's choose C# as our language. Make sure to select the consumption plan under Plan Type. This plan ensures that your functions scale automatically based on incoming events, and you only pay for the actual compute time consumed. Once your function app is created, you'll have a blank canvas to start building your event-driven logic. But before we dive into writing code, we need to establish a bridge between our function app and the Azure Service Bus namespace we created earlier. This is where the Azure Service Bus extension comes in. Section 6, Bridging the Gap. Azure Service Bus extension. To seamlessly integrate our Azure Functions with Azure Service Bus, we need to bring in the Azure Service Bus extension. This extension provides the necessary bindings and triggers that allow our functions to effortlessly send and receive messages from Service Bus queues and topics. Within your function app in the Azure portal, navigate to the Extensions tab. Search for Azure Service Bus and click on the Azure Service Bus extension. This will open up a pane where you can install the extension into your function app. The installation process is straightforward and handles all the necessary configurations behind the scenes. Once the extension is installed, we're ready to start writing code that interacts with our service bus. In the upcoming sections, we'll dive into practical examples of using queue triggers and topic triggers to build responsive, event-driven applications. Section 7, Queue Triggers. Listening for messages in the queue. Let's start with one of the fundamental messaging patterns, queues. With Azure Functions, create functions triggered by new messages in a Service Bus queue. Create a new function and choose Service Bus Queue. Trigger. Provide the queue name and connection string to your Service Bus namespace. The connection string allows the function to authenticate and interact with your Service Bus. The attribute triggers the function when a new message arrives. The message content is passed into the function for processing. Section 8. Topic triggers, selective message consumption. Beyond the one-to-one communication model of queues, Service Bus offers topics for scenarios where you need to fan out messages to multiple subscribers selectively. Similar to queue triggers, you can create Azure functions that are triggered when a message arrives in a specific Service Bus topic subscription. Think of a topic as a news channel and subscriptions as the specific interests of subscribers. When creating your function, choose Service Bus topic trigger as the trigger type. You'll provide the topic name, the subscription name your function should listen to, and the Service Bus connection string. The attribute points to my topic and my subscription, ensuring that this function only processes messages sent to that specific subscription within the topic. This selective consumption model is incredibly powerful for building loosely coupled systems where different components can subscribe only to the events they are interested in. Section 9. Handling errors, gracefully dead letter queues. In real-world applications, things don't always go as planned. Messages might arrive in an unexpected format, downstream systems might be temporarily unavailable, or there could be errors in your code. Handling these errors gracefully is crucial for building robust applications. Azure Service Bus provides a built-in mechanism for dealing with messages that fail to be processed successfully dead letter queues. When a message in a queue or topic subscription exceeds its maximum delivery attempts, it's automatically moved to a corresponding dead letter queue. You can configure your Azure functions to specifically listen to the dead letter queue and implement logic for handling these failed messages. This might involve logging the error, sending notifications, or attempting to reprocess the message after fixing the underlying issue. By leveraging dead letter queues, you gain visibility into message processing failures and can implement strategies to address them, ensuring the reliability of your event-driven application. Section 10. Publishing messages from function to Service Bus. So far, we've focused on triggering Azure functions when messages arrive in Service Bus queues or topics. But what about sending messages from our functions to other parts of our application? Azure Functions makes it equally easy to publish messages to Service Bus queues and topics. You can use the attribute to bind your function's output to a specific queue or topic. In this example, we have a function triggered by a timer that publishes a message to the myQueue queue every 5 minutes. The attribute handles the message serialization and publishing logic, seamlessly integrating with your Service Bus namespace. This ability to both trigger functions based on incoming messages and publish messages from within functions makes Azure Functions and Service Bus a powerful combination for building complex, event-driven workflows. Section 11. Conclusion: the power of integration. Throughout this exploration, we've journeyed through the world of event-driven architectures, delving into the synergy between Azure Functions and Azure Service Bus. We've seen how Service Bus acts as a robust messaging backbone, ensuring reliable message delivery between different components of your application. Azure Functions, with its serverless nature, empowers you to focus on the code that matters, triggering functions based on events from Service Bus and gracefully handling errors through dead letter queues. The integration of these two services unlocks a world of possibilities for building scalable, responsive, and resilient applications. Whether you're building microservices, processing real-time data streams, or implementing asynchronous workflows, the combination of Azure Functions and Azure Service Bus provides a solid foundation for modern cloud-native solutions. As you embark on your own event-driven adventures, remember that the key lies in embracing the principles of loose coupling, asynchronous communication, and event-driven design. With Azure Functions and Azure Service Bus by your side, you're well equipped to tackle the challenges of building the next generation of cloud-native applications.